Good morning, third grade. Yes, do not adjust your screen. This is your math lesson. Today we're going to be talking about tetrominoes, which are these little fellas that you might recognize from the game of Tetris if you've ever played. It's quite fun. The goal of the game is to get one full line. I don't really know how many spaces it is. And then once you have one full line, like this bottom row is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once you have that full line, it clears. If you get to the top, you lose. Anyway, today we're going to be talking about tetrominoes. Were we in school, your teachers would have these little guys cut out for you, and we would be playing with them, and it would be a lot of fun. Unfortunately, we're not together. We're not able to be together. So you're just going to have to enjoy my little rendering here. And if you want to play Tetris on your own, if your parents let you, awesome. I say go for it. Okay. So today, let's look at the bottom. What do we need to do today? It says, reason about composing and decomposing polygons using tetrominoes. So these little shapes that I've made are tetrominoes. And I realize that you don't have any. I'm going to show you a workaround, okay? So don't even worry about it. So let's read number 1 together, please. It says, use tetrominoes to create at least 2 different rectangles. Then color the grid below to show how you created your rectangles. You may use the same tetromineo more than once. Okay, so using these 5 different shapes, we need to create a rectangle. At least two different rectangles, okay? So I know that you don't have these shapes, but I'm going to leave them here, and hopefully you can count how many squares there are on each side and create your own rectangle, okay? So, for example, let's do the first one together. Let's do a kind of simple one, okay? We're going to use 2 different shapes so that it will be simple. So if we what if we put these 2 together and then this one again right here and then this guy. Okay, let's try that. Okay, you're probably thinking, Mrs. Brady, what are you even talking about? So we're going to do, on this first one, this little, I don't even know, the purple one, the pink one, whatever this shade is. We're going to go 2 down. Please trace with me. 1 over, just like that so far. 1 up. 1 over. You have that so far? Okay. And then go 2 down. 1 over, and 1 down. Yeah? Okay. Now we can fit this guy in right here, but that's not a rectangle yet. Oh, look, we can put this right here too. Boop. Yes, let's do that. So I'm going to use a different color to trace this one just so that I know it's a different shape. You don't have to do that, okay? If you want to do that, you may. If it's kind of easier for your eyes. Like for me, it's a little bit easier for my eyes. If I have 2 different shapes, then I know what 2 tetrominoes I've used, okay? And this is the same over here. Let's start from the bottom. We're gonna go up 3 blocks, okay? Or 3 squares. 1, 2, 3. You're gonna go over 2, 1, 2, and we've created a rectangle. Look at that. I think it said color the grid below. So I'm going to color in these little squares of the shades of my tetrominoes. I realize it's a little bit dark, but if I turn on the light, then it gets too bright and you can't see the colors of the tetrominoes. Oh, it's not so bad. Okay, great. And then I'm going to color in this one. So there's the first rectangle that we've done together. What I would challenge you to do, and what I would like you to do, is come up with another one on your own. looking at the shapes that I have. It can be simple. It can be more complex. It doesn't matter to me. Now, if you make a shape that is like this, let's say, you put these together. Is this a rectangle? No. A rectangle has to have two sets of parallel lines. They don't have to be the same length, right? The sides do not have to be the same length at all. Well, they do. These two sides, the parallel sides have to have the same length, but they don't have to, it doesn't have to have 4 equal sides is what I'm saying. Okay? So challenge yourself. I'm just going to leave those here so that you can see. I'm going to move this over a little bit. So you can see how big each of these tetrominoes is, how big each is. And I want you to challenge yourself to create your own rectangle. Meanwhile, I'm going to be doodling over here and trying to create my own as well, but I won't touch those so that you can have a good eye on them, okay? Okay. I'm going to doodle. I might get it wrong. I might not even make a rectangle. But look how much space they gave us. We're going to be okay. How are you guys spending your time in this crazy time we're living in right now? What are you doing with your time? I mean, now you're back in school, right? We're e-learning. But what are you up to? What else are you doing? Are you playing outside? Oh, sorry. Are you reading a lot of books? Uh-oh, what happened? Turn that light off. Oh, there we go. That was odd. Just curious how you're spending your time. Maybe playing board games. We're doing a lot of drawing as a family over here. I got Kinley like a little how to draw mythical creatures book. So she's been drawing like mermaids and rainbows and unicorns, which she has quite enjoyed. Okay. I created my second rectangle using 2 of these shapes and 1 of these shapes. I would love to see what kind of rectangles you created. Okay, let's move on to the second one. If I'm going too fast for you, just pause this recording and come back to me, okay? But we are going to move on at this time. Okay, will you please read with me number 2? Use tetrominoes to create at least 2 squares, each with an area of 36 square units. Then color the grid below to show how you created your squares. You may use the same tetronomo more than once. Okay, so if we were in class together, not only would you have one set of these, you'd be working with a partner to create this. So I understand the difficulty of doing this without having these little guys to work with. If you want to create these on your own, go for it. Otherwise, we'll work together, okay? So we need to have an area of 36 square units, but they also have to be squares. So what does that mean for our side lengths? What do we know about squares, and what do we know about 36? Right. So when we create a square, every side length has to be the same, right? So this side length is going to be 2, 2, 2, 2 for a square. However, that's only going to give us an area of 4, which is not enough. So what should our side length be? They're going to be the same, right? Because all side lengths have to be the same. What does our side length have to be in order to get to 36 square units? Yes, it has to be 6, right? Because side length times side length equals area. So we have 6 times 6 equals 36. So now our task is to figure out how we can create 6 on one side and 6 on the other side. Oh, I keep doing that. Why does it do that? Come back to me. Come back to me. Okay. Okay, so this guy is 3. This is 2. How can we do this? Just have to bear with me for a moment here. Okay, so on this side I have 1, 2, 3, 4, 5, 6. So I have 6 on one side, which is great. But down here I only have 2. Up here I only have 3. So I'm gonna need some more. Oh, why does it do that? I'm just gonna turn this light off. Okay. So we need 3 more over here. We need 4 more down here. I wish I had more of these guys. So if what about this? Use that right there. Okay. Fill in that middle bit. And then I can use this upside down right here to be 5. Then I can use this over here. Okay, let's just draw what I have so far and let's see if we can fill in the blanks, fill in our empty pieces with any of the pieces that we have, okay? We're just kind of flying by the seat of our pants right now because we don't have tetrominoes, right? How else are we going to figure it out? And like I said, we have all this space. Let's just use it. 1, 2, 3, 4, 5, 6. So this whole side is 6. I'm going to continue to use different colors so that I can distinguish between the different shapes. If you want to use colors, that'd be great. If you don't want to use colors, that's okay too. Okay, I'm going to start with this square that we have on the bottom corner. And then on top of that, I put this L shape. Looks like this. And then on top of that, I put this little, I don't know, blue T feller. Little baby T. Okay, so we have one side of 6, which is great, but this side is only 3. So now that I've drawn those, I'm going to use my shapes to see if we can't kind of fill in and get up to 6 on this side and then fill in the middle. Okay, so now we have 1, 2, 3, 4, 5. Put this long one over here. 6. Okay. Ooh, look. We can put this here. And then we can put this here and here. Ah, we did it! I'm so proud of us. Okay, that worked. We Tetrised ourselves into perfection. I'm going to move this over here so I don't forget our configuration. And I'm going to draw in what we've created. 2 this way, up, over. Hopefully you can follow along what I'm drawing okay. Tempted to turn this light on. All right, now I'm going to do the yellow one. A little upside down L. I'm going to put that, kind of bumped those, didn't I? And then we have that little T, little blue T guy. Down here. Fits in beautifully right there, if I do say so myself. And then we'll put two of these squares in the bottom. And one long dog. Look at that. How awesome is that? Okay, so that's one way we created one square with square unit, an area of six, an area of 36 square units. 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6. Yes. So instead of creating this together, what I want to do is challenge you. You have every single shape that we have in here. I want you to make another one on your own that, of course, doesn't look exactly like this, that looks different, that's 36 square units. Take your time, okay? So after this, send me an email with a picture of your new square, okay? I mean, squares are also rectangles, but you know what I mean. Okay. All right. Let us read, please. A, read with me. Write an equation to show the area of a square above as the sum of the areas of the tetrominoes you used to make the square. Okay, does that make sense? What does sum signify? When we're talking about the sum, we're talking about what? Right, we're talking about addition. So the sum is the answer to an addition problem. So if we take all the areas of all of these and add them together, we should get 36. So let's do that. We're using 2 of these. So what's the area of this guy? We can just count all the squares, right? 1, 2, 3, 4. So we have, let's write our equation. We're going to write 4 plus 4. That takes care of these. I'm going to set that aside so we know we've done those. We've already taken care of that. Let's go to the yellow. What is the area of this one? 1, 2, 3, 4. 4 also, and we have 2 of those. Plus 4, plus 4. I'm noticing a pattern. You might be as well. How about the green guys? What's the area of this? Also 4. 1, 2, 3, 4. And we use 3 of those. So we're going to add 4, plus 4, plus 4. And how about this? We just use 1 of these, right? So let's count. 1, 2, 3. Oh, okay. It's 4 naturally. And the last one, 1, 2, 3, 4, plus 4. Okay. Well, look at that. If we add these all together, what will we get? Let's count by 4s to figure out. We should get 36, right? Fingers crossed. Okay. Let's count. 4, 8, 12, 16, 20, 24, 28, 32, 36. Yes. Checks out. Fabulous. Okay. Now down here it says, write an equation to show the area of a square above as the product of its side lengths. What is product? If sum is the answer to an addition problem, product is the answer to a, yes, multiplication problem. So this time we're talking about side lengths. Because one thing I was thinking about, if I counted all of these 4s, I could do the number of 4s times 4 to get this. But that's not what it's asking, right? So I could do 1, 2, 3, 4, 5, 6, 7, 8, 9 times 4 to get 36. But that is not what it's asking. It's talking about the product of its side lengths. So when we multiply side length times side length. So let's just count. You might already know, and if you do, more power to you. But we're going to count just to be sure. 1, 2, 3, 4, 5, 6 is one side length times the other side. 1, 2, 3, 4, 5, 6. And sure enough, 6 times 6 equals 36. Everything checks out, and we're amazing. Okay. Ooh. Okay, this one says, let's read 3A together. It says, use tetrominoes to create at least 2 different rectangles, each with an area of 12 square units. Then, color the grid below to show how you created the rectangles. You may use the same tetronomo more than once. Okay, so this time we're only looking for a square unit of 12. And we don't need to do a square, so the side lengths don't matter necessarily. So long as multiplied together, we get 12. Okay? So again, I'm just going to do, let's do one together, and then I want you to do one on your own and send me a picture. Okay. So this has a side length of 3. So is there a way to get a side length of 4 the other way so that we have 3 times 4 equaling 12? What if we use this again? The other way, right? So we just kind of like use that backwards. Yes, let's do that. Okay, so draw with me, please. We're going to go, let's start just kind of over so you have more room to practice on your own doing a rectangle. Okay, we're going to go 3 down. 1, 2, 3. Cross over 1, down 2, and then over 1. Just like that. Okay. And that goes in the middle. I'm going to draw the other L just right now. Pop it in there. Since I have the yellow out already. There we go. And then I'll use my green for that middle square. And we have 1, 2, 3, 4 times 1, 2, 3. 3 times 4 is 12. We did it. Okay. Let's read B. Explain how you know the area of each rectangle is 12 square units. So, since each of these tetrominoes have an area of 4, how many tetrominoes are you going to use in each shape? 3, right? And that happened here. We could use 3 of these, right? 1, 2, 3. That would be a area of 12. We could use 3 of these. 1, 2, 3. So I'm going to write that no matter what shape, no matter what shape, we are always using 3 tetrominoes because they each have an area of 4. So I'm going to say we know each rectangle, even though we only did one, we kind of explained a couple more. We know each rectangle is 12 square units because each one uses 3 tetrominoes, and each tetronomo is 4 square units. If we multiply 3 by 4, we'll get 12 every time. Boop. Awesome. Okay, let's move on to the last one. Please read number 4 with me. Marco created a rectangle with tetronomos and traced its outline in the space below. Use tetronomos to recreate it. Estimate to draw lines inside the rectangle below to show how you recreated Marco's rectangle. Okay, so really you could do anything because all he did was create a rectangle. It doesn't tell us, it doesn't tell you the area. It doesn't tell you how the side lengths need to be. It doesn't tell you anything. So I'm going to challenge you to create that on your own, okay, using these 5 shapes. However or how few you want to use, and however many times you want to use them, and make a rectangle. So when you email me, I'm looking for 3 things. I am looking for a second square on here for number 2, a second rectangle with an area of 12 square units on number 3, and Marco's rectangle, whatever you come up with. It's a guess. Okay? So make sure you email me that, and that's it. That's it for the day. Have a good one, and I'll catch you on the flip. Goodbye.